So hello friends, in the previous lectures we have done single box mass balance models, and in this lecture we will go for multi-box. So these can be viewed as multi-room mass balance models. Now the equations are pretty much the same. We will go and see how to set up these equations when there are multiple boxes or multiple rooms. So this is our familiar figure where we have indoor environment, which is one room, and this has emissions, inflow, production, which are your sources, and then sinks, which are deposition, outflow, and then reaction from chemical loss. And the mass balance equation is dm by dt for this which is equal to summation of sources minus summation of sinks. Now when we have two boxes, we basically have the same thing repeated. So one box has the same set of mass balance, second box also has the mass balance equations for 1 and 2 respectively. So we have dm1 by dt is a summation of sources in 1 minus summation of sources sinks in 1. So summation sources 1, summation sinks 1. dm2 by dt is a summation of sources in the second box minus summation of sinks in the second box. Okay, so it's basically a repeat. So now when we have two boxes, there are several levels of complexities we can keep on adding. The first is when the first room has an air intake and outflow from the first room goes only to the second room. So it takes the intake maybe from a window, but then the air goes directly to the second room and not outside, and then from second room to outside, and we have emission and deposition in both the rooms. So how will we set up the mass balance equations? So we will have, this is our first room, it has air intake, so I am going to remove the F in. I will just use, or actually maybe I should use F in because F in and F out are different. So we will have F in comma 1. Okay. Hold on. So I will write F in comma 1. This box will have some mass m1. What else happens? Emission is happening in this room. So we have E1. We have also deposition in both rooms. So this room has some deposition. D1. Outflow from the first room goes to the second room directly. So here I am going to join both the rooms. So outflow from here goes to second room. So I am going to make this term F1, 2. So outflow from 1 going to 2. There is a mass m2 in the second room. Then there is emissions in the second room and deposition in the second room. Emissions and deposition in both rooms, and airflow goes from second room to outside. So now we have F out, and this I can make from the second room. So now what are the mass balance equations? First we will write for room 1. So it's going to be d m1 by dt is equal to all the sources. So F in 1 then E1 plus E1. Any other source? No. What is the out sink? Deposition. So minus D1, and also now this flow from 1 to 2 F, so it is minus F1 2. So this is the mass balance equation for the compartment 1. Now what is the mass balance for compartment 2? We have dm2 by dt. Now what are the sources to this room? One is the inflow from room 1 to room 2, so F12. So flow from 1 to F12. Then emissions, so E2, and there is no other production happening here, but we do have a deposition. So we have minus D2, and then the other is F out, so minus F out two. So we have both the both the mass balance equations for each of the boxes written here. Then we have the second option, or the second scenario, where outflow from one room goes only to another room, but both rooms have windows, or other outflow to outside, and both rooms have intakes from outside, and emissions and depositions are in both the rooms. So okay, so we have now a bit mixed scenario. So again, let us mark these things. We have room 1 and room 2. We have M1 in this room and M2 in this room. Both rooms have outflows and both rooms have intakes. So first room has F in comma 1. Then there is emissions also, and there is deposition also. Now we have both rooms have windows or other outflow. So basically this, there will be F out from 1 itself. Then there is transport from 1 to 2, F1 2, then emission into E2, deposition into D2, and we have both rooms have air intake and both rooms have outflow to outside. So we have one F in to intake and F out 2. So this is the outflow. So now we have many sort of flows here. So we will do step by step. We will write first the equation for M1. dm1 by dt is equal to F in 1. What are the other inflows or sources? E1. So plus E1. Any other source is not there. So we will have now sinks. So first sink is F out 1. F out 1. Then what is another source? Sink D1 minus D1 1, F out 1, D1, and then the other one last final sink is transport from 1 to 2. So F1, 2. Let us see, F in 1, E1, F out 1, D1, F1, 2. So these are the sources and sinks for room 1. Similarly, let's write for room 2. So dm2 by dt. Now what are the sources here? Once clearly we can see F1, 2. Then the next is F in 2. Okay, and the other source E2. Now what are the sinks here? First is clearly F out 2, same as F out 1, F out 2, and then one final sink is D2, so minus D2. So these are the broad mass balance equations, and one can of course then always use the rate constants for those equations and develop the equations accordingly and solve the problem. So now we have two sets of equations here. Okay, one more set we will make, which is if I am making a mass balance for the whole house. So this is D1 and D2. Now we will make mass balance for the whole sort of D1 plus D2. So now the internal process of transport from 1 to 2 does not come into picture. So if M is equal to M1 plus M2, which is entire house, we have dm by dt. Now what are the total sources from in the house and outside the house? So F in 1, F in 2, E1 and E2. So plus E1 plus E2. Now out is out, F out 1 and F out 2. F out 1 minus F out 2 minus depositions. So minus D1 minus, minus D1 minus D2 minus D2. So here the internal transfer does not come into picture because this F12, because now we are looking at the entire house. So we are looking at the house from the outside. So whatever happens within the house does not become, because that's an internal transfer. But emissions actually count as sinks, and deposition, because it's taking the substance away from the house, counts as a sink. Emission counts as a source because it's adding the chemical to the house. So emission adds to the source and D adds to the sink. But F12 is just a transfer from one room to another. But since we are looking at one full house, this internal transfer doesn't matter. In fact, if you see dm by dt, this actually is equal to, as we will see, as we have derived this previously, dm1 by dt plus dm2 by dt. So this actually is consistent with dm1 by dt plus dm2 by dt. Then we have the next third situation, which is when outflow from one room goes only to another room, but both rooms have windows, the other outflow, and both rooms have air intake from outside. So both rooms are having intakes from outside and having outflow to outside from both the rooms, emissions and depositions in both rooms. Then we will add reaction loss in both rooms, and both rooms exchange air with each other. So now it is not only one room to another, but now the difference is instead of one to another only this way as well as this way. So both sides air is going now. So now we have to write accordingly, we have to make the figure. So this is going to be very nice figure. We have M1, M2, then we have inflows F in1, outflow F out 1, inflow in room 2, F in 2, F outflow from the second room, F out F out 2. So these are inflows and outflows from outside. Then we have emissions E1 and emissions here, which is E2. Then deposition is there in 1, so we have D1, deposition in 2, so we have D2. Now we have reaction loss in both rooms, so we are also looking at reaction loss. So R1 and here also R2. Now additionally both rooms exchange air with each other, so we have flow from 1 to 2. So let me term it as let us term as F12, flow from 1 to 2, and then flow from 2 to 1. This will be F21. Okay, so now we have basically a lot of flows happening, but there's no need to be overwhelmed. We just have to look at them one by one. So we will go first with M1. So let us write dm1 by dt now. dm1 by dt. So there is F in. So let us see all the sources F in comma 1. Then we have F21, flow from 2 to 1. So we have F21. Then what is another source? E1. So plus E1. Now let us identify all the things. So easiest one, F out. So minus F out 1. What is another sink? D1 minus D1. Then we have reaction losses. So minus R1. Then final one is loss to 2, flow from 1 to 2. So minus F1 2. Okay. F in 1 plus F21, flow from 2 to 1, plus emissions in 1. So E1 minus outflow from 1, F out 1, minus deposition in 1. So D1 minus reaction in 1, so R1, minus outflow to room 2, so F12. So this is for dm1 by dt. Now we will go dm2 by dt. So let's see how it will be very similar to the dm1 by dt equation. Now we will have dm2 by dt. So again we will go in 1. So we have inflows F in 2. Then we have flow from 1 to 2. So plus F1 2. Then we have any other in source term? Yes, E2 plus E2. So we have F in box 2, F1 2, so flow from 1 to 2 plus emissions into, these are the three arrows that are basically adding. Now let us see arrows that are removing. So we have F21, R2, D2 and F out. So we'll go one by one again. Outflow from 2, easy. So F out 2, then outflow from 2 to 1. So minus F 2, 1. Then deposition in 2. So minus D 2 and then reaction loss in 2. So minus R 2. So let us just look again all these sources, F in 1, F in 2, so F in comma 2 here, then coming from 1 to 2, F1 2, yes, then emissions of inside the second room, so E2, then outflow from room 2, F out 2, then outflow from 2 to 1, so F2 1 minus deposition D2 minus reaction loss R2. So that completes the dm2 equation. Now these are the two mass balance equations. Often the F21 is written as a first order function of the masses. So if K12 is the rate constant for transport from 1 to 2 and K21 is the rate constant of transfer from 2 to 1, F12 and F21 can be written, and it is important to note which masses will come, because since mass is now going from 1 to 2, the air is taking the mass in the room 1. So F12 is the air going from room 1 to room 2. So it's taking the mass in room 1 to mass 2. So this will be K12 times M1 because the mass in 1 is going to 2. Now when we are talking about K21, the air from room 2 is going to room 1. So the mass of chemical in room 2 is going to room 1. So we will have F21 is equal to K21 times M2. So it's very important to know or understand that which masses we are going to apply the rate constant for on. So F12 is mass of air flowing from 1 to 2. So we have to do M1 because mass of chemical in room 1 is going. F21 is flow from 2 to 1. So mass of chemical in room 2 is going to room 1. So we will have rate constant K21 multiplied by M2. So once we have these concept in mind, then we can in principle do these mass balance equations and solutions for a lot of simple scenarios. Even more complicated scenarios, they are possible. So in summary, we have looked over until now to set up single box and multi box, so basically 1 room, 2 rooms mass balance models, and in the next lecture we will look at a few examples.